You ever stop and think about how, when you type a website into your browser, the right information finds its way from some server halfway across the planet directly to your screen? It feels like magic, right? Well, it's all thanks to this invisible system that works a lot like the world's most efficient post office. Today, we're going to break that system down.
I mean, seriously, think about it for a second. There are billions, with a B, of laptops, phones, servers, even smart refrigerators all connected to the internet. When you ask for a video or shoot off an email, how in the world does the network know which device is yours? The answer is a really simple but powerful idea: a digital address.
So, let's pull back the curtain. To really get how this all works, we have to start with the most fundamental piece of the puzzle, that digital address itself. It's the thing that makes everything else possible.
An IP address, which stands for Internet Protocol Address, is pretty much exactly what it sounds like. It is the unique address for your device on the gigantic map of the internet. You know, just like your house has a specific street address so the mail carrier can find you, your phone or your computer has an IP address so the internet knows exactly where to deliver data.
Now, what's really crucial to understand is that this address does two things at the same time. First, it's about identification. That's the who, making sure the data is for your specific device. And second, it's about location, the where, so the network knows where to send it in the first place. It's just like an envelope needs both a name and a street address. An IP address handles both of those jobs for every single piece of data you send or receive.
Okay, but here's where our story gets a really fascinating twist. The original system for these digital addresses, the one created way back when the internet was just this tiny network for researchers, well, it was not built for the world we live in today, not even close. It was about to run into a huge problem.
4.3 billion. That's the total number of possible addresses that were available in the original system, which is known as IPv4. Now, back in the 1980s, that number seemed impossibly huge. I mean, more than enough for every computer that could ever possibly exist. Spoiler alert, they dramatically underestimated things.
And this really puts the scale of that problem into perspective. We now have way more devices online than we have available addresses. Every phone, every laptop, every smartwatch and gaming console needs one. We were literally running out of internet real estate, and we were running out fast. A new system was desperately needed. So the solution was a complete, total upgrade. The old system, IPv4, was built on this 32-bit structure with 4 blocks of numbers. Its replacement, IPv6, is a massive leap to a 128-bit format that uses 8 blocks of letters and numbers. And that one change expands the number of available addresses to a number so ridiculously large we'll probably never run out. It's the future-proof solution to the internet's big address shortage.
But that's not the only clever trick the internet uses to manage all these addresses. See, it also uses 2 different types of addresses at the same time. And to understand this, the best way to think about it is to use the analogy of an apartment building.
Okay, so first up, you've got a public IP address. This is the single main address that your internet service provider, or ISP, gives to your entire home network. In our analogy, this is the street address of your whole apartment building. It's the only address the outside world actually needs to know about to send mail to that building.
Now, once you're inside the building, every apartment needs its own number, so you know which door is which, right? Well, that's your private IP address. These are internal addresses, and you've probably seen them before. They often start with 192.168, that your router assigns to your phone, your laptop, your TV. They only make sense inside your local Wi-Fi network.
Which, of course, leads to a pretty logical question. If my laptop only has a private apartment number that the outside internet doesn't even recognize, how does it get information from the web? How does data find its way from that main street address to my specific device?
The answer is a brilliant piece of tech that acts like your building's digital mailroom, or maybe a concierge. It's called Network Address Translation, or just NAT for short.
So here's how it works. When your laptop wants to go to a website, it sends that request to your router. The router, our digital concierge, takes that request and it slaps its own public IP address on it as the return address, and then sends it out. When the website sends the data back, it comes to the router's public address. The router, being very smart, remembers which device asked for it in the first place and forwards it along to your laptop's private apartment number. It's a completely seamless translation service. Now, this little system is incredibly important for two big reasons. First, it lets a whole building's worth of devices share just one single public IP address, which really helps conserve that limited supply of IPv4 addresses. And second, it adds a nice layer of security. Since the outside world only ever sees your router's public address, your individual devices are basically hidden from view, which makes it much harder for unwanted traffic to get to them directly.
Okay, one last piece of the puzzle. We know you have an address, but is that address permanent, like a P.O. box you own forever? Or is it more flexible, kind of like a temporary hotel room number you get when you check in?
Well, there are two types. A static IP is fixed, it does not change. This is your permanent P.O. box, and it's absolutely essential for things like web servers that need a consistent, reliable address people can always find. A dynamic IP, on the other hand, is assigned automatically, and this address can change from time to time. This is more like a temporary forwarding address, and it's perfect for most of us at home.
So, take a guess. The IP address that your internet provider gives to your home router, do you think it's static and permanent, or is it dynamic and always changing? If you guessed dynamic, you're absolutely right. Almost all of us have dynamic IPs for our homes. For your ISP, it's just a much more efficient and cost-effective way to manage their pool of public IP addresses, just handing them out to customers as they're needed.
And that really brings us full circle. This simple set of numbers is the foundation of our entire online world. It's the invisible, unsung hero working constantly in the background, a simple address that connects your screen to a global network of knowledge, entertainment, and connection.
So the next time you browse a website or stream a movie, you'll know a little bit more about the incredible digital postal service that makes it all happen. And you know, it kind of makes you wonder, what other complex, invisible systems are hiding in plain sight, just powering our world, waiting for us to understand that?